Welcome to the second lecture. We have quite a lot of contents today, but the topic is unit testing, or I would probably call it low-level testing or programmers testing or something like that. But unit testing is the topic, and we're also going to mention test-driven development. Yeah. So. Yeah, I'm probably gonna have a bit of technical issues today. 2 computers, and I will probably take the wrong computer every time, like I did now. But my name is Daniel Toll. I'm a passionate programmer, passionate tester, and your lecturer. And hopefully, most of you are properly registered on the course now. So hopefully I addressed all the registration issues last week. At least those who signed the petition form was registered on like Wednesday or something like that. But if you're not registered on the course, sign the petition form. I know there are 2, I checked the form this morning, and there were 2 people who had joined the petition form this morning. And so please do that if you're not registered. And you can check registration on Ladok. So the other thing is that I know that there are still a lot of students who did not join Slack yet. But it's on Slack you will get your answers. And if you ask me questions by email, I will kindly ask you to seek out the answer in Slack. So I will answer you in Slack. And that is because most questions you have, other students will have them also. So only personal issues to me, like registration issues or something like that. And it's really important that we get a good community around the course in Slack also, so that you can find and rely that you get good answers from each other also in Slack. Okay. This is the content of today's lecture. So during the lecture, we're gonna have a bit of repetition from last week. So I've put all these slides for that repetition in the beginning, but I think that it might be a bit boring to do all these repetition things or all the questions. So I will just do a couple of them so that you get used to it in the beginning, and then we will go back to those, perhaps, if we have time and like that. Okay, then we're going to talk about unit testing, and then we're going to talk about test automation. And I say X unit testing, but the X here could be any sign for any language. So it's just automated test framework, like JUnit or NUnit or whatever, really. There are many of those. So I'm going to show you a little bit of JUnit code, and this is going to be some ready-made examples and also some writing of code. Then we're going to talk about the hard cases. So hopefully you practice a little bit of unit testing until this week, right? Or at least checked up on it a little bit. If you haven't, the hard-to-test code and the mocking part will be a bit hard to follow, perhaps, and you might want to recap this lecture later. And then we're going to address the quality of test suites, like we addressed a little bit before. And then we're going to talk about agile testing and test-driven development. And in the end of the lecture, I'm going to do a bit of demoing of test-driven development so you get a feel for how it's done. Yes. Any? Sounds like fun? Yeah. Awesome. Okay. So we're going to start with a couple of questions. And these questions are on stuff from the last lecture, right? So it's just to recap some of the vocabularies we had. And it's sort of yes and no answers to all the part questions. If it's true, if the statement or question is true, you should say yes. And then you raise your hand in the room, or you raise your hand online. Could you please raise your hand online so that I can see that you know how it works, right? Awesome. So 7 out of 21, 8 out of 21 people have raised their hand. Oh, at least 11 people are online and awake. So if more than half of the class says that, raises their hand on one of these, we consider it true, right? So you can remove your hand if until we see the first question. So this is the first question. Okay, what is the goal of testing? Who thinks that the goal of testing is to completely verify that the code is correct? Please, you raise your hand now. None in the classroom and none online. It's because it's not correct. That was verification, right? Is the goal of testing to uncover errors? Please raise your hand if you think that is true. What's an error? Yeah. So 8 people online. Depends on what's an error, right? An error was the mistake done by the programmer, right? So testing could be to uncover these errors, or at least the faults, that is the effect of the error, right? I do mistake, I do an error. I in thought or in action, I make a mistake. It could be miscommunication with my client. It could be that I'm actually producing a bug in the software. That is the error. But the bug in the software is what tests are going to uncover, right? I guess that if we're talking about error in communication and stuff like that, we could let the customer test our product, like a beta test or something like that, or a acceptance test, and that way uncover the misunderstandings that have occurred. Okay, is the goal of testing to build confidence in the software? Awesome. At least 10 people, 11 people online, everyone who is awake online, 12 people, 13, awesome. And most of the class here, yes. So as programmers, we need to be confident that the software works as intended. So we want to gain that confidence somehow. And by just writing code, we won't get it. But perhaps by testing the code and see that it actually works as we thought it would, yeah, that builds confidence. And that allows us to make changes, right? If we make a change, we sort of loses confidence that the code still works. We might have broken something. If it's really complex code, we might have broken something. So we need to rebuild that confidence. And regression testing, for instance, is a way of doing that. Okay, how many think that the goal of testing is to prove correctness? Okay, not so many. Prove correctness. Correctness was 100% reliability, right? That means for every input, we produced the correct output. And that was the same thing as the topmost alternative. It was verification, right? So testing is not to prove correctness. And most of the time, if we're doing a testing approach, I will show that it's probably not feasible to do that. And you have to use other kind of methods to do verification. Okay, so we're going to skip this. Oh, I think that we skip this one. We'll take this one instead. So if we have a fault or a bug, that was the problem in the code, right? Or the actual result of the error, or the result of the mistake. So can that be found in any of these? We start with the system under test. So can we have a problem in the system under test? And we have 11 people online and sort of halfway raised hand in the classroom. Oh, yes. The system under test is the class or method that we're testing right now, right? So it can certainly contain bugs or faults. So the actual code or the actual output from the code. OK, the specification, can that contain a bug? The specification was how we specified this software. So 10 people online. What do you think here? At least 3 people started raising their hands when 10 people online said their thing. OK, 12 people online. Great. OK, the specification could also have a problem in it, right? If I misunderstand my customer, I create a specification that includes errors, right? So if the customer says, I want a pink page, yeah, because they have that kind of weird voices, the customers, right? So, since I'm employed at the university, I never meet customers, right? So, but pink could be something else for the customer than for me. So I do like a pig pink color, and the customer thinks something else, right? So it's certainly the specification. OK, the requirements. Yeah. So free. Oh, yeah. Sort of. Yeah, the requirements are the sort of what we get from the customer also, right? The specification is the specification for the software, and the requirements is part of that. So the requirements, what we're going to do, or how the software is going to solve some problem for us, could also be buggy. And perhaps it's not buggy in the sense that we've misunderstood the customer. Perhaps it's buggy in the sense that it will not work, or it will not sell, or that there is some contradictory requirements that do not work together. So actually, we can stop now, because all of these can contain problems, right? The operating system can contain problems, right? I mean, if you're using Windows, you're used to this, right? If you're using Linux like I do, I had one of these this morning. I mean, the hardware, yes. Who hasn't got a broken hardware sometime in their life? I mean, broken graphics card that have been too heated up during tough gaming sessions and never want to produce correct graphical output after that. Of course, and drivers and stuff like that, right? So the problems that we seek out could be in any of these. So we need to be inventive, and we need to be open. I've said in the last lecture a bit of cursing, right? But the assumption is the mother of all fuck-ups, right? It's almost always when I don't understand how my software can produce a certain output that is faulty or buggy or like that. When I don't understand, it's because I've assumed that something should work that didn't work, at least not in the way that I thought it would. OK, we're going to talk a bit about inputs here. So let's do this one also. So the input domain. So what was that? So I've got a bit of Java code here. So who thinks that the topmost alternative, that A is +5 and B is the letter C, is part of the input domain? None. Thank you. So the letter C is not an integer. It sort of could be translated to an integer, at least in like a lot of languages. But in C++, for instance, a letter like that is a character, is a number between 0 and 255. So it sort of could translate into an integer, but it's not an integer. OK, the second one, 0, 0. Is that part of the input domain? Awesome. So a lot of hands. Good. -5 and the integer value of 4.3. What do you think about that? 7 people online. What is int value? Okay, the integer value of 4.3. So that would be 4, right? So it's just confusing stuff. Okay, then you understand. So that is probably also part of the input domain. All positive numbers. No. Okay, so numbers could be larger or smaller than can be represented by an integer, right? So, and this includes numbers that are floating point numbers and stuff like that. Do we need to say the negative ones? No, we don't. Okay, any number in minus large number 2 plus large number if an integer is a 32-bit number. Who thinks that? 8 people online, like 7 or something people in the classroom. Yeah. So we need to know the digits, right, for a 32-bit number to decide this. So I think, because I changed the number of one of those, and I don't really remember which. Right? So one of these might be correct and the other one is not. So we need to know. But I think both is actually part of the input domain. It's just that the last one is a bit smaller. Right? So the input domain is all values that a system under test can take as input. Actually, in most programs, the input domain is huge. I mean, not just this small 4 billion number input domain. It's really huge. Yeah. So I will skip a few of this. Oh, we can take this one, just because it's sort of a joke. Okay, who thinks that SUT means structure under test? Actually, there is such a acronym, but it's not what we mean. Single unit test. None. State under test. None. System undefined testable. Thank you. State unknown together. No. Stupid unnecessary test questions. Yeah, or at least like 8, 9, 10. Thank you very much. I give you a small applause for understanding humor. Oh, system under test. Anyone? At least I hope, entire class. Oh, good. Because we're going to use that sort of acronym now. Okay. So a short recap is that testing does check conformance to requirements. It gives us a deeper green understanding of the requirements. Build green confidence in the software and code, and uncover green problems, errors, defects, and bugs. You can just ignore the green. Okay, it does not prove that the program is correct. And the reason that it does not is that even if we could test the entire input domain, we can take this program and sort of put it in another environment, and it might not work in that environment, right? So we just tested it from one environment. Okay, wrong computer. Okay, so unit testing was the subject of today. So unit testing is when we test a single specific unit. It could be a class or a method. Most of the time, I think of a unit test as just testing one method through one set of input. It can be done manually. I'm going to show that soon. We can automate this process, and we're probably going to do that. And when we automate the process, I'm going to show that also. We are probably want to do certain stuff like getting reports out of the system or from the testing. So it could be a good idea to use an automation framework. So we're going to provide an example with that also. And we could also use some random testing to test this. And I'm just going to sneak peek. Yeah. So a single unit test mostly often contains of some set of input and an expected output. the expected output was decided by the oracle. So the oracle is the one who decides that output is correct or not. It could be a person, and most often as programmers, we do create this expected output. And many times, I've been in the position that I don't know what the expected output is supposed to be. That could be either a sign of misunderstanding or don't understanding the requirements, have not decided the requirements, or that it's just a weird output and I'm unable to understand it. I've done a bit of like physics simulations. And sometimes you like, okay, you have this really complex mathematical formula and not that simple example that I have here. And I input any number and I don't understand the output. So if I don't understand the output, I cannot decide if it's the intended output or the expected output or not, right? So it's like, okay, we input like 4.6 and the output is 9.4. But if you don't understand what happened inside this method, if you cannot produce this expected output, then it's sort of hard to do this, right? And you're probably gonna feel this when you're doing the first assignment. So that, okay, I'm gonna write the test for something, but I don't know what the expected output is. So it's sort of about trying to find out this and sort of understanding how to make this simpler so that we can test it. So I've chosen a simple method called max. It takes an array of numbers, and it should return the maximum integer in that array. So we have an input array of 1, 2, 3, 4, and the expected output is 4. The actual output, we get that from exercising the system under test. So in this case, the system under test is the max method in my math class. So the actual output is what we get from the system. And then we match this. We check if it's the same as the expected output. If it's not, then we know that there is a problem in my code. So I'm just going to sneak peek to the next. Yeah. And then we're going to code. Awesome. So we have a method here. It's called getMax and not max anymore because I tried to refactor my code. And it takes an integer array. So 1, 2, 3, 4. And I've introduced an error in this code. No, I've not introduced an error. I've introduced a fault or a bug, or a couple of bugs actually, in this code. The error was intentional in this case. It was not, it's actually both. Intentional and unintentional errors added. But you don't get to see the code here. We're just going to do some testing of the code. So it should return the max number in a set of inputs. Really simple stuff, right? We don't have a problem of creating expected output in this case. Or at least I don't hope that you don't have. So we're going to start by doing manual unit testing. So I've written a small program. It creates a myMath object, and it also creates a buffered reader. That is the way of reading the console in Java. Actually, there is a class called console also in Java, but it's sort of not usable in Eclipse, at least not for me. So I create this buffered reader stuff. And then it has this run method, and it really prints out a nice menu, and then read from the console an integer array, and then we check if this getMax method can be called. And it prints out the max value of that integer array. So let's try it out. And the run computer. I'm probably going to do that a couple of times. So 1, 2, 3, 4. The max was 2. Oh, it's not working. So let's perhaps try another one, like 3, 4, 2, 1. Oh, it's 4. It's correct. So this certain implementation does not produce correct output for all inputs, right? For some inputs, it creates incorrect output. Yeah, so let's try the reverse one, like 4, 3, 2, 1. Oh, we get an exception. So the exception in this case is an array index out of bounds exception. So that is sort of a programmer's error, right? And I can actually see that it happens in my math. So this is the feedback that I get back from this test. I get feedback that the test works for some inputs. No, the code works for some inputs. The code produces wrong output for some other inputs. And the code produces like exceptions for another kind of inputs. So yeah. Are you with me so far? Too complex code? Okay. So what do we gain from testing? For a specified input, the program either works as specified or provides unexpected output. Unexpected in the sense that it was not what we expected a functional or correct implementation would have. So what is the value of these? Just take 2 minutes and discuss among yourself. You can write in the chat and you can talk here in the classroom, and then we'll rejoin and see what kind of answers we come up with. What kind of value? Sorry? So what is the value of these two? So what is the value of a test result that works and a test result that does not work? Or the test result actually works, but the system under test has a problem. Okay, so from the online students, we got awesome answers. So I'm going to read up those. If it works, it provides confidence in the code. If it not, we know that we need to change something, right? We either gain confidence in the code or we know what to change. Either we know it works or we need to change something. Yeah. Works as specified, then provide room for improvement. Yeah. Okay. So if it works as specified, we get feedback that we've done something okay. At least the change that we did not wake up the demon in the code, right? So, or at least that the number one is at least that we know that for this specific input, we didn't get a faulty output. Actually, they've I don't know how, but they've calculated the value of tests, and it seems that old tests that almost never produce a faulty output or no an unexpected output actually decrease in value. So old tests tend not to discover new bugs. But we can still gain confidence from it. It's still nice that the green light show up and we should see that, okay, it works for all inputs that we have tested, right? If we didn't change anything, it produces no value. It's only when we change code that it produces value, right? If we have an implementation that we know awoken this green light before, or that the test works as specified, or the code works as specified, and we rerun that test without doing any changes, that is no value, right? If the test suddenly flickers to red and provides unexpected output, then we at least have something to go on. And the good thing here, by having a unit test or something that is small, some way of reproducing this, is that we can also use that for debugging. So I can run the debugger and I can find the problem. So in this case of index error out of bound exception, I can see on what line that exception is thrown. Right? So we could probably go right in and fix that bug. Yes. Okay. So what is the input domain for get max with an array of input? Anyone? So at least these arrays, right? There could be a lot of different arrays. Infinite number of arrays, not that large. With integers, ran out of memory, big, yeah. So, so it sort of depends on how large these numbers can be, right? And it also depends on how large the integer array can be. Anyone care to calculate the number? Wrong computer again. It's sort of 2 to the power of 32. That is the value of one integer, right? And then you have like the number of items you can have in an array. And someone said on Stack Overflow, so deep information search, is that you can have like 2 to the power of 32 minus 5 items in your array. So yeah. So it's, a null could probably also be a part of this, right? An empty array or null could probably also be a part of this. It's sort of, yeah. For each method that you have, you need to specify what is the valid input to this method. So in this case, I would consider null not to be a valid input. If you're providing null to this method, you're probably doing something wrong elsewhere. So I'm totally fine if this method does not handle null. Do you understand my reasoning? So as programmers, we can decide that the valid input for this are only arrays for like 10 items or something like that. We could like simplify that by producing this code. So I allow every input as integer arrays, but it's only designed to work for 10 items, or mostly 10 items. Or it's only designed for working for null or not, right? So, but the difference is that so we can design things that inherently has problems in it by like simplifying the kind of interface. If I only wanted 10 items, if I said that I have that requirement, I could either change the interface like to throw an exception if it's more than 10 items. Or I could create a specific class that only takes 10 items. So I replace this integer array with a class that takes 10 items and that fixes that problem. Or I can just ignore it like I've done today. So yeah. Or I can document it. So I can write in the specification or in the documentation of my method by a little bit of Java doc that, okay, valid input for this is mostly 10 items. So, so the input domain could be smaller than what we actually allow programmatically. In the case of non-typed or weakly typed languages like Java, JavaScript, I mean, if I don't have like TypeScript or something like that, we allow any input, and only input that fulfills the requirement of the code inside will work. In Python, we have this duck typing, or what it's called. If it quacks, it's a duck or something like that. You can look it up. So we could sort of try to limit the input domain by other means, by providing a specification that you're only allowed to send 10 items into this. Or you could actually do something. I really like to produce classes that, or methods that only take valid input by design, by typing. It makes testing so much simpler. Then I don't need to create all these weird examples with the billions of examples. Okay, yeah. Yeah. So we've done manual testing. Manual testing was, you saw me, I had to type. I needed to come up with good examples. I needed to, if I now want to reproduce this bug, perhaps for debugging, I need to remember which input that worked and did not. 1, 2, 3, 4 worked, not, no, it didn't. What other examples did I have when it worked? So it sort of get lost. The process of testing, at least if it's not supported by some kind of process document or something like that, or if I don't make notes, then it's lost. So by doing automation, I can save this process, and I can also make it quicker. So I've just done a really, wrong computer. Really naive test here. So I'm going to close this one. And this one creates an input array. We have an expected output. We exercise the system under test by calling the method getMax, and I produce an output called actual. And then I test these two against each other, and wrong computer. And we see that, oh, the test succeeded. And it was a bit faster than typing these numbers, right? So I sort of gain in speed here. But when I wrote this test, that took time. That probably took more time than writing these numbers in a manual test. So the nice thing about it is that when I have written them, these tests, and I want to reproduce this bug by regression testing, I can do that like a snap. So really fast testing when I've actually written these tests, at least if I've done good. Hopefully, if I do it good, the test freak says that the kind of test you write can be used as a specification of the software. So we can capture requirements in the software by writing executable tests. So we get an executable specification. Yeah. Something that is also nice is the bit of tool support that this can give you. Both you can have traceability. So you can, by naming or stuff like that, connect a test to a requirement or a test to a piece of code. So you can have traceability from these. So that will have debugging, and that will help to see if certain requirements are implemented or not, and stuff like that. We're going to discuss coverage later. But the last part is that okay, it's an initial cost. You have to create this test, you have to write it, you have to debug the test, and you have to run it. So it costs a little bit more than manual testing normally. And it's an initial cost, but it's also cost over time. If the software change, you're carrying a backpack of these tests with you. And this backpack also needs to be changed if the code is changed. So if you have a gazillion of tests or just 100 tests like I did for a really complex method, so I've implemented a really complex method but with like 100 test cases. So it was that complex. It was like human language input and then other stuff output. Yeah. And then I changed this method, the interface of this method and what it did a little bit. And it was really a hard time to change all these 100 tests for it also. Because all of those suddenly became a burden instead of a benefit. Right. Okay. I'm going to ignore that. So I said that we've tested manually. Testing can be automated. You've seen an example of that. It's an if statement, right? We can also use an automation framework to do this. And the automation frameworks have other benefits. So let's say that I want to increase this test suite. A suite is a couple of tests put together so that it finds the bug also. So if I change this number here to 2, I think that the test will fail. So but this is still, if I just change these numbers until I find a bug, that is sort of a manual testing, right? It's just that I can exercise the set and I can decide if it's correct output or not. That part is automated, but the actual writing of the input is not automated. So if I instead do the awesome thing of copying code, let's do it like this. I'm so lazy right now. But and then we create another example like that. Oh, then I produced. So now I had 2 test cases in my test suite. And the first one failed and the second one produced an error. And let's see if we can create another one that also produces the correct output. And it should be like this. And I need to run that before the one that crashes the program. So it failed. I don't know why it failed. Oh, expected output. Oh, that is a bug in the test, right? Yeah. OK. So now I have one failed, one succeeded, and one that causes an exception. And you can see that I'm copying code. And if we have copied code, what are we supposed to do? If we have duplicated code, I mean, what are we going to do? What is the action programmers should spring into if they see duplicated code? Refactor. Yeah. And we could refactor by creating a method. And we could, like, if we just look at the code, this part, this if statements is a big part of it, right? So if I could just have a method that has such an if statement in it and produces output, that would be a good part to refactor. And also now that I get output of different types, this test failed, test exception, and test succeeded, I might want to say that for this input, I got this output, and that was a failure, right? So that I know the starting point. I might also want to be able to have a good starting point for debugging. And the only good starting point for debugging is right now the array index out of bound exception. So a test framework creates this for us. So we have these if statements, and they are called asserts instead. Yeah. So they are called unit tests, or JUnit test is one way, and one way of calling it. And this is a simple unit test using JUnit 4. And you can see that it has two methods. It has a setup method, and it has a test method. And the setup method in JUnit 4 has this @before sign. In JUnit 3, it's supposed to be named setup, I think. Yeah. So you can see that setup method creates the system under test, or that, and for every test method, the setup method is called before it. And then we have a test method, and this test method is called should return the last highest value. Something like that, and we have expected value, and then you can see that I exercise the system under test, and then I have an if statement, and it's called assert equals. Assert equals is just a method that runs an if statement, and if the if statement fails, it will throw an exception called an assert exception, but with a bit of message, so that I get more information on, okay, you provided this input, and this was the output. So if I run this test, and the wrong computer again. I get a detailed report. So we can see that I've run, they should return last highest value, and I get an assertion error. An expected value of 4. Please. No, it's not going to work. An expected value of 4, but it was 2. OK, I get a question. What is different between assert and then return in mock objects? OK, these are really different things, and I will talk about mock objects later. But I think that now you need some coffee. And while you are drinking that coffee, perhaps you can take a look at this question and see if you think that any of these are true. Okay, we will be back in 10 minutes, so 10 past 10. Okay. So it's 10 minutes past, and I'm going to restart the lecture. Of course, you can ask questions. If it's a suitable time in the lecture, I will always try to address the question directly. If it's not, we try to take them a bit later. Okay. So what do you think about these testing activities? The same thing as before. We raise hands. Yeah. So beta testing is done during coding. 2 people. Yeah. I guess beta testing is when you release something to the customer, right? And you say that, okay, this is our upcoming game, or this is our upcoming application. Would you please test it? Or do you want to participate in this beta testing program or stuff like that? So you could be programming at the same time, but it's not part of the beta testing normally. Yeah, but it could be done at the same time. So, okay, unit testing is done by programmers. All the people in the classroom, none online. So yes, unit testing is done by programmers. So the programmers have knowledge of the code, so they know that this piece of code needs to be tested. Then have perhaps just written the code. They want to test it, make sure that it works. So yes, it's done by programmers. So these unit tests are normally not written by specific testers. I mean, the difference between being a programmer and a tester, at least in agile testing, is really small. I don't know if you've checked the agile testing video that I asked you to look at. And you can see that she was this tester person, and she's suddenly become part of the programming team. And according to me, that is exactly how it should be. A tester should be a programmer should be a tester. We could have these sort of not qualified testers, people who don't know programming, who are testing our software, and they could have other qualities. Perhaps they have the customer's best wishes, best thing in mind. I could not come up with that word. Yeah. Okay, but they would normally not do any unit tests because they don't have any knowledge of the units. Yes. Sorry, Imad, I did not understand the question really. Okay, so regression testing can be automated. How many thinks that? Oh, you forgot the definition of regression testing. Yes, and that is the entire idea behind doing these slides, right? So regression testing is when we've changed something and we retest it. So I've written code that worked before, then I change something, perhaps do a refactoring, remove some duplicated code, and then I run the same test again. So now, do you think that it could be automated? 4 people online, 6, 1, 2 in the classroom. Yes, it can be automated. Every time I run my unit test suite, every time I go to Eclipse and run my suite here, that is regression testing. So this time it did not produce any value, though I already knew that it was a problem and I didn't discover a new problem. I didn't change anything, but it can be automated. Do you think that customers should be involved in testing? Three people online, almost the entire classroom. Yes, I think so. I think the closer you have your customer, the better chance you have to actually do what the customer wants you to do with the customer's money. So yes, I think they should be involved in testing. Okay, thank you very much. Let's go back to So we've seen JUnit really fast now, but there are other XUnit tests frameworks. So for Java, there are JUnit 3 and 4. There might be more, I have no idea. For .NET, we have NUnit. There are a lot of different, it's like Microsoft Test Framework or something like that. I don't know what it's called. Did anyone use for PHP, we have PHP unit. Yeah. For Python, we have PyUnit. JavaScript with JS unit, JS test driver. A lot of stuff that I don't know about. I mean, there are dozens of unit test frameworks. And in this course, you're allowed to choose one of for your interest, right? So if you're good at one specific language and you want to dive deeper into testing into that language, you can use that test framework. It should be fine. So, so what do these frameworks provide? Well, one thing we've already seen, and you can see the small screenshot here from JUnit, and that was a report. So we can see that some tests are green, some tests are red, and some tests are blue. and green means that the tests for that class succeeded. The red means that we have an error. That is most in the case of Java, mostly exceptions thrown. And in some parts, it could be blue, and that means a failure. That is an assert exception that has been thrown because we did not produce the correct output. Yeah. So most unit test frameworks works as this. You have some kind of test classes. So for each class of what you want to test, the system under test, you create a test class. So you have a 1-to-1 ratio, 1-to-1, yeah. And perhaps you have also a method in your test class for each method in the system under test. But in many cases, I would say in most cases, you need more than one method, test method to test one system under class method. And these test classes have some way of doing these if statements. In JUnit, it's called asserts. You can have different test suites. So you can group certain tests into a suite. For instance, you only run the test for a small part of the software. So if you have, I don't know if you took a look at the Google video, but they have hundreds of thousands of tests. So even if each test runs really fast, they have a problem that running tests take time. So you might want to run a subset of the tests, only the tests that are for the part of the source code that you want to test. So, so these test frameworks allows you to group tests into different suites. You could have a specific suite for a specific component in your program or something like that. Or you could have integration tests put in one suite and stuff like that. Yeah. And this framework also allows you to run these tests and produce reports. How that is done could be like console commands, or in this case, I push a button. Some of these frameworks also provide code coverage. Code coverage is a way of knowing what part of the code have I tested and what did I not test. And that is also part of the first assignment. And some of the students here in the classroom said that their test framework of choice did not have a working code coverage tool. So how are we going to, can we use this framework still, and how can we learn about code coverage and how to use that? And if it is the case that your code coverage is not implemented for the tool that you're using, I want you to take a look at another language or another framework that has code coverage, just to see what it is, what it does, and how it works, right? So you can still answer the questions on the examination and show that, okay, I took a look at code coverage, and it just happens to be the case that when I prepared for this lecture, I couldn't get code coverage working in JUnit. JUnit itself does not have code coverage, so I have a tool called Code Cover, and you can enable it for a project, and there are different types of coverage. But now I enable it, and you can see, oh, I get all these build problems. I have not had time to fix that problem. I will show code coverage soon, but in another project. So I have no idea why that didn't work. So I get a question, can you show an example of equivalent partitioning and BVA test? Equivalent partitioning is a part of another lecture that addresses how to produce these test cases. Equivalence partitioning is or does not have to be a part of unit test, but it could. It's good to have that kind of thinking when you're doing unit test, but it's not mandatory here. So that is sort of another lecture. Yes. Okay. frameworks could also have room for mocking, and this is something that I think is a requirement. You need a mocking framework in order to do proper testing. Mocking framework allows us to test things in isolation. So, why do we want to test things in isolation? Let's go back to the code. And let's go back to the manual testing application. Did I remove that? Yes, I did. So, didn't rebuild the code. Yeah. Okay. So, yeah. So let's produce one of the bugs. Well, that didn't do it. Yeah, that one. So when I do this, I get an index out of bound exception in my map. But it could be that the manual testing program is actually containing the bug. It could be that this code, wrong computer. And this code, a lot of untested lines in this code. This one could be the one that contains the bug, right? It could produce input that is not allowed, perhaps a null or something like that. And that is why it's index out of bound. Right? If I have a bug in this code, it could be that the problem that I find is not due to the implementation of getMax. It's in this code instead. It just looks like it's part of the getMax. Actually, it's part of the getMax, but this code is totally untested. I mean, I wrote it this morning, or perhaps some of it yesterday. So it probably has bugs in it, or problems in it. But if I cannot decide if it is this code that is buggy or the getMax code that is buggy, then I have a problem. If you run your entire application, you do a system test. You start up the application, you input stuff into the application, you get a faulty output, an unexpected output. You don't know which part of the software that produced that output. So it would be kind of nice to ignore this code and only test the getMax. So testing in isolation is really nice. And in some cases, that is really hard. For instance, if you have dependencies between classes. The getMax method did not have any dependencies. It did not have any, didn't use many other classes, right? It just used an integer array. But if you have connected classes that have relationships, then you want to make sure that you find the errors in the system under test and not in one of the dependencies. And that is why mocking is really good. Yeah. OK. So by running this test, by running the unit test, I'm only testing the system under test and not the other one, right? But if it had dependencies into it, if it used some kind of other class, then I needed to be able to separate these two. But what if I need one instance of the other class in order to even start up this test? Then I need mocking. OK. So I think that yeah. And the case where we have dependencies, the last point here, is just one example of hard-to-test code. Hard-to-test code is code that you cannot easily produce a test for. Some of these are if you know the technique for it, you can avoid it, sort of. But if you don't, it could at least feel as hard-to-test code. Error handling, for example, if you have code that throws exceptions, you need to know a way of testing that code. In most frameworks, like JUnit, you can actually produce tests that expect an exception to be thrown. So it's not that hard. The hard-to-test code with error handling that I mentioned here is more or less code that handles errors. And the reason that it might be hard to test is that when we are in the programming action and we are forcing our way through the requirements and we are implementing a lot of stuff, we tend to focus on getting the important stuff working, right? And when we focus on getting the important stuff working, we tend to try and ignore problems because I just want it to work. The customer wants this implemented today, and if the database is not online, I don't care about that error. So I write a piece of code that either hides that error or just, just don't handle it very well. And then I never test that because my database is always working, right? So error handling often becomes untested or untestable code, just by design by the programmer, just by the mindset of the programmer when he's implementing and trying to reach the main success scenario, right? Trying to get that work. So I realized this, that myself when I'm programming, that I tend to focus on getting stuff to work. And the error handling code, because I'm still writing error handling code, often contains a lot of bugs, and it's not usable as I thought it was. But I mean, it could also be really simple. You just design for error handling, you just throw exception if there is a problem, and then you make sure that the chain of calling handles those exceptions. I mean, it's not that simple. It's not that complex, I mean. Okay. User interactions are also like hard to test. How can I write a unit test when a user is pointing the mouse to a certain place on the screen, drawing a line perhaps in this drawing application or something like that? How can I write a unit test for that? So if you're asking that question, you sort of have a too large unit. So then you're thinking about system testing, really. But it's still a problem that some parts of the program that perhaps like input and output is not that easy to handle. Output to console is often a side effect, really. So the programmer wanted to have some debugging output from a program run. And within a method that produces output values, he also did a system out print line call, something like that, a print line to the console. And he never intended for that code to be perhaps a part of the working code, or it's just a side effect. So in order to test that part, we need to wrap the system out so that we can catch that, or we can wrap the console in order to do that. Yeah. Yes. So this system out, I don't know how much Java you know, but system out is a static thing in Java. So static means that we don't need to create an instance of the class, right? We can just call the methods on it, or and those things are often hard to test also, or creates that kind of things, because you cannot see this in the interface of the class. Okay. yeah, I can see in your eyes that I might be a bit away here. And what you consider hard to test, I hope that you will find these things when you're doing this first assignment. This is the reason that I want you to do this assignment properly and spend a lot of time doing it, and perhaps challenge yourself to test a bit harder things and test some user interaction and stuff like that. Because I want you to discover the problems and I want you to solve them, right? So, yeah. So hopefully you will find those and you will solve almost every one of those by mocking. That is what I hope you will find. So one case is that we have a dependency to a database. And that database is sort of slow, right? It takes milliseconds to run that database. It's really slow. If you have 100,000 tests and each test takes a millisecond, it becomes 100 seconds of test running time. And that's, we don't want that, right? So one car manufacturer that I talked to, he was responsible for the test process. He said that setting up and running their test suite took 2 weeks of runtime. That is just computers working, automated tests running. 2 weeks of runtime. The reason for that is that they have not isolated dependencies. They are more like, in our vocabulary, they were actually doing more like integration testing and actual entire system test than unit testing that we're talking about today. But it still gives an example that if you have dependencies to things like disk drive or database, that makes the test slow because the test need to invoke calls to this database, it needs to wait for the response, and that takes time. If tests that writing files is the same thing. Tests that call an API is the same thing, or the web API at least, right? Network communication. That takes time. And the problem here is that we have a dependency. So we would like not to have this dependency in the test. And mocking steps in again. So if I could replace, just for testing purposes, replace this database with a fake database, a fraud database that just replies directly, I can get a much higher speed. And I also get the benefit that I can test my code and not what is in the database. So the idea here is that we create what's called stubs, test stubs. I would so much want to draw stuff, but I guess I need to start another software for that. So I got the question, is there any simple program would do for the first assignment? So I've given you an example in the assignment, so there you can check out this sticks example, but you could do any programming. I would start really simple to begin with and then write a small console program or something like that. But I want you to spend enough time to discover these hard to test things. Okay. Hopefully we can draw now, right? So there is our database. And we have our system under test, and it has a relationship here. So the reason this is bad is that if there is a problem, you get a red, oh, it's an X, right? A test failing. You don't know if there is a problem here or if there is a wrong data in the database, right? You have no idea of that. Also, the second problem was that the connection to the database took time. Also, when you're starting up the test, you probably want to produce a certain state in the database. For instance, if you're testing that, can I log in with a user that exists in the database, you need to make sure that user exists. So you need to produce certain states. You need to set up that database. You need to perhaps even start up the database. And I think that for the car manufacturer that spends 2 weeks, I guess most of the time is like starting virtual servers with databases and stuff like that, and making sure the state is correct. So it also takes time. Yeah, that is a clock. 12, 6. Okay. So instead of this situation, we would like this. SUT. During test, we replace that database with a stub. The stub responds in the same way as the database, but we can design how it responds. So let's take this case with user login. In this topmost, when the application is running as it should, there is a user in the database. So let's call him admin or something like that, and it has a password. And what the system under test does is that it has a select question. So it's asked, OK, I want to select the user with the name admin from the database. And it expects a record coming back with the user credentials for that. But in the case down here, we can have a fake class that looks like a database that takes a select or has a select method. And we can ask that method, we call select on that one, or query or something like that on that object, and it directly returns a user credentials for the admin. So that is stubbing. We replace something, a test stub. Yes? Yeah, stubbing and mocking. So I'm using the vocabulary from one of the videos that I posted on the course web page. So stubbing is when we try to remove a dependency. And we replace that dependency with a fake object or fake database or whatever that just responds in the same way as the other one. It solves these two problems, right? Stubbing solves both the problem of testing in isolation, so that we don't get errors because the database is in the wrong state, and it solves the time issue, more or less. OK, mocking is another thing. Mocking is when I want to verify that a certain call has happened, that I talk to the other class in a certain way. So, OK. Yes, to quote the guy in the movie, everything is a stub until you assert that something has happened to the stub object. Then it becomes a mock. Yes. What's the difference between a mock and a spy? OK, so spies are when you try to sort of stub and mock the same system under test object. So it's sort of a sign of hard to test code, for instance, private methods and stuff like that. Yes. Yes. So stubs can't result in problems. I get a question. Yes. So if this, the assumption here is that the stub sort of works in the same way as as the database, right? If it does not, then we have something else. Then we're testing another situation, right? So if you call a database with a select query and it responds with there is no item for that, then you have another case, right? Okay. So in this case, I have a class. Oh, you don't see it. In this case, we have a class. And this class is called dice game. This class has two dependencies, and they are dependency injected into the constructor. It's called the dice view and the dice model. And since they are dependency injected into the constructor, we can replace them with stubs. In the run method here, you can see that I'm using these different objects. Actually, I'm more or less only using the view of these because it's not a working example. But in order to test this run method here, I need to stub out perhaps the view. So the way of doing it, so here we have a test suite or a test for this dice game, is that it's actually called mocking even if I'm using it for stubbing. So I'm using a framework called Mockito, and I can just say that I want to mock the console wrapper class. And then I get an instance that works, or no, that looks like it has the same interface as a console wrapper. And then I can just dependency inject that into the dice view. Oh, I'm in the wrong class here. But you can see in the same way here. I create a system under test, but I mock its dependencies. So the nice thing about mock objects is that I can configure them to answer in a certain way. And that is the same way as with the database. Since I want the database to answer in a certain way, I can design that. So in this case, the game should quit when the user press Q. So we need a bit of understanding of the code to understand this. So while do quit returns false, we're continuing into in the game loop. So we have a do while loop here, and we're going to continue as many iterations through that loop until do quit returns true. So since I want to test something, we don't really need to understand what I want to test in this case. I need to configure the mock object to first respond that I want to continue in the loop and then return true and quit the loop. So in this case, I say to the mock object that when a call is made to the do quit method, oh, something is weird. Yes, it is. Okay. So technical issues, right? So Ivar says technical issues. I say not tested. That is true. I have not run this lecture for a year, so yes. How do you know that the test you're doing is actually accurate? Okay. If I have a specification, I can always check the specification, right? If I have requirements, I can always check the requirements. But this is an issue. What we decide is true is not always what should be true, or so to speak. So the test could, and probably are, containing problems. But the test, at least, when you're doing test-driven development, should contain what you believe is the truth at the time. Then that will change. OK, so I configure the mock object, or the stub object in this case to return false when do quit is called the first time. So that is a way of configuring the stub to work in a certain way. And that was to remove dependencies so that we could speed up time and also test this system under test, the dice game, in the isolation of its dependencies. You can see that I've also created this behavior. So in the case of the line up here, it's a stub, and then I test the system under test. I call the run method on it. This is the exercising, but then I don't have an assert down here. Instead, since run does not return anything, it does not throw any exceptions, I cannot test it, right? It's sort of hard to test because it's behavior. It's calls to a method. So here comes mocking. So suddenly, instead of testing an output, I can test that a call has been made to a certain method. And what I test in this case is that show input menu has been called twice. So the verification or the assert is actually on behavior instead. So I say that on the view stub, this show input menu should have been called twice if this code works. So instead of testing output, we're testing behavior. Probably some of you have heard of behavioral-driven development, right? It sort of builds on this. So instead of testing output from a program, we can test that the program behaves in a certain way, right? And behavior in programs is really a method calls, or it should be. What makes my implementation of this easy to test instead of hard to test is that I allow dependency injections. Since I input these dependencies in the constructor of the object, I also allow myself to mock them. If these objects, these dependencies, were created inside the dice game class, then I would have had a hard time mocking them, right? Because I don't have access to the creation of these. So stubbing and mocking works hand in hand with something called dependency injection. So dependencies like the database make it harder to test. Solution is that if you have a class that relies on a dependency, you inject that dependency through the constructor or one of its methods. And this allows us to replace this dependency with a dummy or this stub object. Yeah. Yes. So in let's ignore that one. So sorry, Adam, I really don't understand. So that it's still the question on how do you know that the test you're doing is actually accurate, or yeah, okay. So then I continue, right? So mocking allows us to test behaviors and remove difficult dependencies. And that was just some ad for Mockito. So behavior was that we inject a mock object and we check that methods are called after. And in Mockito it looks like this. You can verify that a certain method is called on a certain object a certain number of times. You can also have, I think, this one, that you assert that a certain method is not called. In this case, it should stop and show exit message on quit. So I want to verify that it shows an exit message, but I also deemed it necessary to verify that it never calls the show result on the model. when I was programming this. So we could also like have a negative way of seeing testing, right? We assert that something did not happen. Or, yeah. Okay, something that I said was also a bit difficult was the system out calls, or the dependencies to static things, really. And the solution to this one is that we can mock them also. So you can see that I have a class called console wrapper, and that class is just mocked, and the input, you can see that I read line from this console wrapper, and when I call read line, it will return a specific input. So I just configured that certain console to return what I want it to do. In this case, I have a dice view, and it has a quit command. So, and the quit command is just, if we take a look at that, it's just these messages. And you can see that I have put these messages in public static strings. And the reason for that is to minimize the duplication in my code. So we can also mock that was the input. Here we have a method that does not provide any output other than to the console. So it writes things on the console, and I just verify on my, in this case, a mock object, that it actually writes the exit message. So that becomes a test that we produce the correct output. Yes. Yes, mocks use behavioral verification. That is true. Okay. So that was sort of quick pass through the world of mocking, but I will return to it when we do the test-driven development demo in the end of the lecture, or pretty soon. So, okay, now we have a way of making these automated test suites. Now we need to convince our customer that we're doing a good job testing. One way of doing that is to show that every line of code in our program is covered by some test. And that is called coverage. There are different types of coverage. And as I said, I had a bit hard time to show this to you in my project, since it didn't want to work. So I'm going to show it in another project. So this is a web server that I wrote, and I'm going to run it. So here we're running some integration test that takes a bit of time. And then I get a test session report. And in this case, I'm going to click out yesterday's and start that one. And we're going to check the source now and see some coverage over the source. And you can see that in this case, I just clicked on a really small class, but the green lines means that these lines are run in a test. I don't know which test in this case, but it's actually run. So okay, there were all these exceptions. So let's check code, and you can see that in this case of this try catch, I have covered both the try part of the statement and the catch part. So I've tested the error handling also, right? So here is the test report. And you can see that most of the tests succeed. Not sure why this one does not. Oh, yeah. It's probably that I have. There is actually a failing test. Data one assumes that I have access to internet and an online server, so that is why it tests. It's part of the integration test suite. Okay. Now I'm not sure how to show this to you guys. Might be here. Yeah. So this is the coverage report. You can see that 98% of this code is covered. So the interesting part here in this case is what is the remaining 2% and why is that not covered, right? And you can see that actually these 2% seem to be in server and in HTTP server console. So let's take a look at that. The main method is not tested. Anyone know the reason for that? Anyone tried to test the main method with JUnit? I'm not able to test it in JUnit. I don't know why, really, but I haven't been able to do it. If you succeed, please tell us. The main method in this case is just factory code. It really creates instance of the application and dependency inject stuff into it. But suddenly, with very quick means, we could find untested code, right? So the value of coverage is two things, right? We can show to the customer, oh, check this, it's all green, right? You can trust us. And the second thing is that I can find stuff that I need to be better at testing, or that I did not yet implement testing for. Let's take a look at the other part, and I'm in the wrong computer. The server was not properly tested. A client thread class. Oh, it's error handling code. And actually, oh, this might even be better than that. Take a look at this. Nah, okay, it was not. This code, I've had a hard time testing it. I think it could be very easy to test by mocking, really. So I don't know why I've not tested it. Probably something that has changed, right? If I refactor my code, I might forget, or I might create untestable code. It could be the case that I'm actually having code that cannot be tested at all. Unreachable code. That is possible. A simple example would be to create an if statement that checks if a variable is true, and inside that if statement, you create another if statement where you check if that variable is false. And then you have some lines of code, right? Those lines of code can never be run if the variable cannot change state. In that case, we could have that, but so it's fairly simple to create untestable code at all. It could also be the case that by some design you have done, you're unable to invoke this certain IO exception. I guess I could invoke it by mocking, but it might be the case that it probably can in this case, but I guess this close call, if that never throws an IO exception, if it cannot even throw that IO exception, that is also dead code, right? And don't need to be tested. So this could be, yes. So you want me to upload these mini demos somewhere? Yes, sure. Yes. I think that this web server code will be a part of another assignment. So you will see it there. You will try to run these tests, and you will try to understand how I've done it. I wouldn't say that this is the most awesome code ever and best tested ever. I was sort of learning test-driven development while I did this, and this was my sort of example of doing that. But you're welcome to learn from it or to criticize it. It's all okay by me. I said that we could have different test suites, and I have at least in this one, I have not created the actual suites, but I have a part of this that are integration tests instead of unit tests. So I'm using a unit test framework for integration tests. Integration test was the sort of opposite of mocking. So in an integration test, I want to connect. I want to have dependencies because I'm testing dependencies, right? So I'm testing that things actually work. And at least one of these is actually a system test. I think it's the stress test, where I run the server for real and have clients that are connecting to it and stuff like that. Okay. So that was coverage. We could get a report. The type of coverage that is shown was statement coverage. Has this line or this statement been run? There are different types of coverage, and you're going to look it up yourself because I think there is a question on it on the first assignment. So, but look up code coverage. There are different types of it, of different levels. So the next way of testing quality of test is called mutation testing. So how do I know if the test, in the case of coverage, I could have 100% coverage and not learn anything more than that the program did not crash. If you create a test and you don't assert anything in that test, you only run the code, right? No? Right? Oh. Okay, you might need a break, right? So I can create these really stupid tests that only run the code. Or are they stupid? Could be a smart test also. It's called smoke testing, really. So, but the coverage itself does not say anything if the code worked as specified or not, right? Because I didn't have any asserts. So coverage could be pretty useless. So how do I know that, how do I differentiate, separate good test suites that find problems from these stupid test suites that don't find problems, that don't has any asserts at all? One way of doing that is that we create a lot of faulty implementations. And then we run these two test suites against these faulty implementation, and the test suite that finds the problems, that is the good one, right? So if a test suite is good, it will find problem. If it's not, it's not going to find problems. And that is the basis of mutation testing. In mutation testing, you create this faulty implementation. And it's really simple, really, if you know how to do it. You take the source code of the working system under test that we hope is working, and you think of that as a working version of the program. And then you remove a line from that, perhaps on random. Or perhaps you remove a call to a method. Or perhaps you add a call to a method. Perhaps you are changing a comparison operator. So if you have an if statement with an equal sign, you replace that with a not equal sign. If the test suite is discovering this problem, we call that a good test suite. If it does not, we call that a bad test suite. And that is mutation. It's really simple in some languages. Like in Java, we have awesome mutation testing tools. So the mutation testing creates a score for how good this is. And that is the fraction of problems that the test suite could find of these. It's sort of, it sounds really great when I say it this way, right? Mutation testing has problems also. These mutations can create this kind of untestable code and stuff like that. And then it's, yeah. Yes. Imad said, or asks, all these coverage in white box? Yes. So when we have coverage information, that becomes, and we create a new test, that is white box testing, right? I suddenly have knowledge of the code, and that is white box testing. Okay. So there is also something called checked coverage. I think that for today, it's sort of a complicated subject, so I might want to leave it for later. And I might want to prepare an example for it. So we're just going to ignore that. But checked coverage really means that we see or calculate what instructions in the program that was actually tested by a certain assert statement. So we only call a statement covered if that actually contributed to a certain assert statement getting a certain result. So it's trying to solve the problems of code coverage by doing sort of advanced called dynamic slicing of the program. We're trying to find only the statements that affected a variable. So we're trying to find what is tested and what is not. As an example, you can have, let's say you have a method, and this method returns the maximum value of an array of integers, right? In that method, you could also have a system out call, right? In this system out call is not tested by any assert statement that is only checking the output of the method, right? No? So checked coverage would find that the system out call is not tested, even if it looks like that in checked coverage or in normal coverage. Yes. This is, yeah, we've already shown that, and test-driven development. But we're going to have a short break before we're stepping into test-driven development. So let's take 10 minutes, so 20 past 11. And get up and move a bit, get some air. Yes. So in this case, I call it agile testing, but and this is sort of what do you call it when you rewrite history? Just to give you an impression, but yeah, sort of a lie. As much of things we say is. Okay. Before agile testing, we had requirements, and these requirements led to system testing. System testing was that we tested a system as a whole. Might also have been a bit of integration and unit testing, right? But testing mostly, and still mostly, happens after the implementation. So we write tests, or we do tests after we have written the code. And that is sort of normal way of doing things if you ask many programmers. And if you looked at the agile testing video, you can see that she's so amazed that in their new team there was no conflict between the programmers and testers, and that she was welcome and loved, as she says. You should really look at that video. It's a bit old, but it shows you a bit of the spirit of agile testing that I want to give you. If programmers are a separate group and testers are also a separate group, and as in one case when I interviewed a tester, he said that the testers were giving bonuses for finding problems, and the programmers were given bonuses for not writing problematic code. And in that case, the testers and programmers really hated each other, because if the testers found a bug, it meant that a programmer would get less money, right? Less bonus. So, and that is a destructive way of doing things, really. It was probably meant as an incentive for both of these groups doing good job, but it's really a destructive way of handling things. Okay, since testing only happened after implementation, this means that the time until we could release a new version was very long, like weeks. If you imagine that the test suite takes 2 weeks of running, like in the automation industry, you will not be able to fix that problem before that is done, right? Before you get that test suite. And when you have fixed the problem, or you think you have fixed the problem, you need to retest this, regress and test it again. That means that regression testing is painful. Someone has discovered a bug, I fixed the bug, someone has to test it again and not find it. Okay, we both had manual and automated tests. Agile testing changes the place of testing in the process of programming. Requirement still leads to testing, but testing is done during implementation. That is, programmers and testers in a team together write tests and are conducting testing while programming. And this means that if I write a small test and I find a problem early, I can have a short turnaround time within seconds. I would say that if your test suite takes more than like 20 seconds to run, you should probably do something about it. I like my test suites to be really, really quick. I want them to like in 2 seconds, 3 seconds. Yes? Then I'm talking about only unit test suites, yes. The implementation, or the integration and the system test suites that you can implement during unit test frameworks probably does take a longer time, as you see in my test suite also. Okay, focus is on automation of tests, and we do that to have a smooth and really quick regression testing. We want to have confidence to make changes. If I need to do a really long testing process after, I will not do the change because I know it will cost me. So test-driven development is test first compared to test last. So we can have unit test and not doing test-driven development. It's a low-level software development process. It's the only software process that I know of that is on that level. That is really code close. It says what you should do when you're coding and not a software process as a whole. It's not a thing you can say to like 500 programmers, follow the TDD software process. It's not that. That is like Scrum and stuff like that. But it's a low level, so it's 1 or 2 programmers working with their code. Some say that it's not testing, it's design. I agree on that a little bit, because when you're programming in test-driven development way, you need to decide how the program is going to work. And when you're writing your test, you're actually designing, but on a small scale. I would not do TDD sort of on the large scale. It's sort of hard to think of the big pictures when you're working with the small details. So, and TDD is working with the small details. So you could still have an architecture of your program, you can still have a design of your program, but you're writing the actual code in a TDD manner. In this course, it's sort of controversial to have TDD. In this course, I hope that it will force you to think of testing in a certain way, if you think of how to write testable code. Because if you must follow this procedure, you must discover certain problems that is to this. I don't say that TDD is the silver bullet that will shoot down every vampire and every werewolf that you will meet in your programming life. I don't say that. I don't say that it's simple. I don't say that it's better. I just want to show you, I want to force you to experience it, because I think it will give you value as programmers and as testers. Yes. I know that it's awkward. Okay. Is it better? There's some research from IBM and Microsoft that indicates that TDD teams take 15 to 35% longer. And these are really good programmers. I know there are really good programmers in this class. And it will probably take like 200 to 300% more time for you guys. Especially if you have not written unit tests before, especially if this is the first time you're doing TDD. But it will get better. And that is why I said 60 hours of working with this. Because I want you to like get through the first obstacles of TDD and the first awkwardness, and then build upon that, and then learn how to do it more efficiently, and then learn how to refactor your test, and then learn how to avoid all the problems and stuff like that, right? So you, in the end of this course, you're on the 15 to 35%. I guess these teams had done a couple of TDD projects before. It's really weird how they compared these teams. It was different projects and stuff like that. How do you know or estimate how long a project will take? So please don't take this as the awesome truth of everything. It's just a report by some companies. But they also say that it took more time, right? But it decreased the number of bugs, the density of bugs, by 40 to 90%. Only 40? Oh my God, 90% less bugs. In some projects at least, this will have a real effect on the usability of the product, right? Of the product. At least if the troublesome bugs are found. Yeah. Any very simple program would do for the first assignment using TDD. Yes, start with a really simple program, then continue to more complex stuff with user interaction. Okay, what is TDD? It means red, green, refactor, and that is a mantra that I want you to repeat. Red means that we create a test. We write a unit test, an automated unit test using some of the frameworks. We run all the tests, including the new one, and the new one should fail. You're not allowed in TDD to write a new test that succeeds. And we talked about value of test. A value of test, or a test, is most valuable when it finds a bug or a problem. So that is why we do that. You should not add too many tests to your test suite, because that will increase your backpack that you're carrying for the rest of the project. So you only want to add tests that fail. Then you make a little change to the source code. And you run all the tests, and you should get them all to succeed. That is the green. So the first was red. Write a test that fails. Then green. Make that test with a simple, small change. Stupid even change. Make it succeed. And then, when you have it succeeding, then you remove all the trouble that you've added to your test. Since regression testing is really cheap, since you can run all the tests again, you have a large test suite, you know that when you're doing refactoring, you can feel safe, you have confidence to test it again. Remove duplication. It's very common to add new tests by duplicating them, like I've done today, right? I added another if statement. When I refactor, I can remove this duplication, and then I can run the tests again. Yes, David?
Is it the git commit at step 2 or on slide?
So in assignment 1, yes.
If you want to commit at step 2, step 4, and step 5?
So in assignment 1, since I want to see that you've really followed this and that you have not cheated, right? So I want you to write a test, and then you run that test and see it fail. And then you do a git commit. Yes? And you name that commit red. And then you make a little change to the source code. And then you run all the tests again and see them succeed. And then you do a commit. And then you name that green. And then you refactor your code, make that work, and then you do another commit and name that refactor. If you should feel that it's necessary, also do a coverage measurement to see that, okay, I've actually covered my code. Yes. But, yeah. Should we test each method by itself and commit one by one? Yes. You only write one test for one method. Yes. So in this case, I've actually not followed it, but that was because I want to show you guys two things. And this case is that we have a Sudoku board, and this Sudoku board has a constructor. And the Sudoku board's constructor should throw an exception. And I just wanted to show you two ways of doing this. The topmost one is the JUnit 4 way of doing it. So the expected output, if you send a null to the Sudoku board constructor, would be to have an illegal argument exception thrown. Right? So the expected, no, I can't write on this one, but yeah, I can write. Awesome. Suddenly it worked. So this is actually the assert statement, so to speak, in this framework. How you do this in different frameworks differ a bit. You can always, in a test, have a try-catch, and since this one should throw an exception if the code is working correctly, we don't have anything in the catch. That is OK. That is the expected thing to happen. But we fail if we can run the line below. This is sort of a mind leap for some. So we add this test to the constructor. You should only add one of those. And wrong computer. And then you run it, and you see that they fail. It fails. In this case, I have two. So stupid. But then I make a little change. This was the simplest change I could do. Actually, I could even be even. Oh, I want it to. So it's not working now. Who tested this system? OK, I could scratch that if statement, right? If I only had this test, it could always throw an illegal argument exception. That would be the simplest implementation of that code, and it would succeed the test. So I make that change. And I get back to green now. So this is green. All tests succeed. And I refactor my code. In this case, I had a duplicated test that tested the same thing, so I removed it. And then I retest it again with green. And that retesting was called regression testing. So we refactored and we tested again, make sure that we didn't break anything. Yeah, and then we write a new test. Red, commit, green, commit, refactor, commit. So when I did this myself, I use command line git. So a small writing of a couple of macros is probably a good idea. Yeah, just to make sure that you don't feel the burden of doing these commits is making you avoid doing these commits. Let's say for last year, the students that passed this first examination very easily was the ones that had like 200 commits. The ones that we started to ask questions or harder questions was the students with like 20 commits. And some of these students had been practicing TDD before or really knew all the answers, and some didn't. Some didn't realize when they got such a open assignment that they should actually do something, right? So I want you to be programming, and I want you to spend time on this. Yes, and it's for your benefit. In my first commit, I pushed a red, but to make it work, I had to add and implement a lot of code. These will all be tested, of course. Should I commit again now that the first test succeeded and create a new test for another method? So you're allowed to learn. You're allowed to make mistakes. So in this commit history, in the beginning, I expect there to be like problems, or I expect you to make mistakes, or not following the TDD process. But in the end of the commit history, I want them to be perfect, right? So it's very easy to start writing code and then test it afterwards. It's so easy, and you just want to do it. I mean, I'm not programming TDD normally, and I actually don't think that I will get much time today to do it. But I sometimes go back to it, and for certain problems, like when I have a complicated method, it's so useful. But it's so hard to follow these things if you don't like have someone who smacks your fingers when you're not doing it correctly. So yes? For this first project, yes, you're supposed to do 3 Git commits for each change, so to speak. Yeah. So 50 tests would be around 150 commits, yes. I think that you will probably realize that you're going to get a lot of tests, especially if you do this test pong thing where one student write a test and then you write a simple implementation that is not correct but fulfills all the tests. You will get a lot of tests. And if you don't refactor things, you will miss out one big thing. And the big thing with refactoring is that it's so easy to implement duplicated code. If you're starting to, I'm just copying this test, and I'm just copying this test, and I'm copying these assert statements and stuff like that, then you'll miss out on a big thing of thinking, how can I minimize this? And the problem with that is really that you will not learn the benefit of this, really. You will only experience the problems. If you're starting to refactor, and in the end of this lecture, I have 3 books that I encourage you to read on this. None of them are on the course literature list, unfortunately, but maybe they should be. Let's take them now. So this one is by, no, yeah. This one is by Kent Beck. He's sort of the testing guy, sort of the TDD guy. So he's giving Java examples. So he's working with an example, showing how to make it more testable, showing how to write these tests, showing how to follow the TDD cycle and stuff like that. But it's Java, and it's sort of very code intense. So if you don't like code intense and you want more theory, then you should find another book. Yeah. If you want to find out good patterns for writing your test and good patterns for thinking of writing tests and ways of refactoring not only your source code but your test suite, then you should read this book. It has a slightly different vocabulary than we're supposed to use in this course, but it's still a good book. Yeah. It's more a book where you don't read the entire book, but you check up on a problem, or you want to read something specific, or you want to learn something specific. And then we have Clean Code, and I love the book, but I don't subscribe to everything he says, as always here. Clean Code by Martin. It's C. Martin something, Robert C. Martin. It's a book about the craftsmanship of writing code, and TDD is a part of that. So, and he's trying to simplify his code, and he's using TDD as a mean of that. So that is more how to take it a step further and write really good code. But TDD is one of the tools he's using for that. Yes. Okay. So 200 commits, is that a figure number or a literal number? I think one of the tutor instructions had at least like 250 commits or something like that. Don't remember, but yes. What if you got a private repository? I think that you should have a public repository. You should not do a secret project here. I mean, it's about learning. If you would like to have a private repository, then you share it with the tutor instructors during the examination, or yeah, something like that. I sort out my program with only 5 commits. Too simple. Yeah, yes. And probably my guess is that if you had just 5 commits, you didn't follow TDD. Yes. So you said it is possible to be a good tester without being a programmer. How is that possible with huge demand on coding for the assignment? Just speaking on behalf of all non-professional programmers taking this course. Okay, so this course prerequisites is a lot of programming courses. So if you're applied for this one and got accepted on, you should have those prerequisites. You should have a lot of programming courses in your baggage, yes. If not, I'm sorry, then you, yeah. This course is not all about programming, but testing is a big part of programming. Programming is a big part of testing. Well, yes. Okay, so we will do a bit of TDD programming. So I will just create a package, and we're going to call it the Sudoku. So I don't know. We don't have much time, but I will address this this TDD just as simple as possible on the time available. Okay, so the idea is that we're going to make a Sudoku game, and where are we going to start? We're going to have some kind of console application or user interface application. It might be too hard to work on the interface first. So I would start with something simple, like like maybe the game rules or something like that. So let's create a class called Sudoku board. It has no methods right now. It's totally fine. But we're actually going to start testing it without methods.
Now we create a code before we create a test.
Yeah, but it's really not that much code, right? But I mean, maybe a TDD fanatic would argue on that. Yes, you're a TDD fanatic. Sorry about my misstep. But I mean, I'm also learning, right? So I'm not claiming to be a super expert on everything or anything. Okay, so I'm going to create this. Normally, I would place this in the test folder. So we're going to do that. Or normally, I call that the tests folder, since it has, and not in the source folder. And the reason for doing that is that I want to separate the system code from the test code. Actually, you would like to have these two completely independent of each other. But yeah. So you can see that this is the automated tests, and it actually fails. So I've reached my red, but it does not have any real implementation. So Sudoku is a numbers game, right? And we probably should have some kind of board class to capture the domain rules of the Sudoku board. And the first thing we're going to test is that if we're going to create a Sudoku board, we must send it an array of 9 numbers. No, 9 times 9 numbers, right? So we only create a Sudoku board with 9 times 9 numbers, so an integer array with exactly 81 numbers. But let's start even simpler than that. Just create an instance of the class and send it a null. And I'm allowed to generate source code. And I'm allowed to like work on the interface of my methods. It's sort of, I mean, the reason that I'm allowed to do that is because the test says that by just compiling the test, I can see that there is a problem. So by just compiling and getting a compile error, that sort of counts as red. Yeah. Everything depends on how fanatic you are. Like that. OK, then I'm not going to touch it. Oh. So like this. This test, if I run it, will not fail. So it succeeds, right? So I'm not in red right now. And that is problematic. So I should make this fail. And I've shown you before that, at least in my web server project, I had tests for exceptions. So let's find one of those. If I can find one, this one, right? No. OK. So if I send a null to the constructor, I want an illegal argument exception to be thrown. Now I can rerun this test, and it fails. So I'm allowed to make the simplest change that I can. So I'm going to do that. Like that. I rerun the test, and I should get a compile error, right? And I don't remember the, like that. What is wrong? Oh. An error in the test instead. So now it succeeds again. So now I'm on refactor stage, right? I'm on green. I should do refactoring now. I don't have really any code duplication that I should think of, but I have a bad name for this test. So I rename it should throw exception on null input, because that says more than test. I follow this sort of naming standard that I have this should in the name. It's sort of from BDD practice. Yeah. Yes?
But you encourage to implement so stupid code as you did just follow it.
Yeah, so that was really stupid implementation, right? I think that if you want to have it's sort of this test pong thing. I wouldn't do it in production. Okay. But it could be a kind of fun way of programming. Yeah. So let's make another test that complements this other test. So if I should not throw an exception on correct input. Like that, something like that. That should not throw an exception. I'm actually produced a bug in the test right now. because this input will not be correct, really. It will have like an not allowed thing. But for now, I'm just doing it, and I'm rerunning these tests. So rerun this test. Make sure it fails. It does. Then I'm allowed to change the implementation. And I just do the other thing, stupid thing, the most stupid thing actually, this is not that stupid, right? This is probably going to be there in the production code that if we send it a null, then we have this illegal argument exception thingy. Oh. OK, I rerun, and both tests succeed. Then it's refactoring time. I don't see any really, yeah, we sort of do have a duplication, but not yet. This 81, the number of items in a correct board, is sort of a duplication of a rule that will be in the model. So let's create another test. And now I need to think of how should this work? What kind of problems could we introduce? Maybe if I send it an array of 80 items, it should also throw an illegal argument exception, right? Should throw an exception on too small input array. I do?
Should not throw.
Oh, sorry. Naming bug. Yes. So only 80 of these. It sort of actually has a duplication thingy here also, but let's ignore that for now. OK, now I have a test failure, and I can go on and make sure that or board on length 81, right? If it's not 81, it's not a correct board length. It should throw an exception. I retest. It works. OK, someone who has taken a test course before maybe think that, oh, is there any other numbers we should test here, like 79 or 82? Wouldn't it be good to test 82? 82 is not smaller, it's larger, right? So I just duplicate this to large input array. OK, and then we run this test. And what happens? Oh, it succeeds. So this last test is not allowed. I'm not allowed to add it. Actually, I forgot about refactoring also. That was another mistake. But I'm not supposed to add this test, even if it's sort of by testing practices. When we're going to talk about how we're going to create these tests later on, it could be a good thing to test on both sides of this number, but not really here. We're not supposed to do that, because the implementation right now does not allow us to get red on this. So in that case, you need to change your implementation to something more stupid, and you're not supposed to do that. So actually, I'm not going to carry around this test. Instead, I'm going to refactor this and remove this too small and say that on incorrect input array size, right? That was a way of refactoring. OK, now I have this 81, and that exists even in the Sudoku board class, right? So we have a number duplication, a magical number, and that is code and data duplication. So we create Sudoku board dot array size like that. And I'm spelling like should create a static. And I'm still in refactoring, right? I'm just rewriting my code like that. So now I've rewritten my code. I may have introduced some problems, so I rerun my test suite. I do the regression testing, and I'm fine again. Yes. Actually, I've got something that I'm, from a non-TDD point of view, would not like, and this is this one. Why is this not good? I can change it. No, it's that is not. It should be a constant, really. So it's a static final, so we can't change it. Anyone? Sorry? It's internal rules of this class. So I'm exposing internal behavior in this class, and I'm doing it only since the test needs access to this. So it could be solved, sort of. For now, I don't think that it's that important, so I would leave it like this, because I think that maybe in the future, when we have some kind of view and gonna render this Sudoku board, make some graphical interface to it or something like that, we're probably gonna need to know how many fields there are on it, or so to speak, right? But it's really, I'm showing how the class works on the inside. So that was really short presentation of TDD, but the time has run out. So maybe we need to continue on the next lecture, and you're always allowed to ask questions on Slack or during the tutoring sessions. Yes, or actually I'm counting on you to do that. So I probably have some unanswered questions that I've not seen in the chat, so please repeat them and I will answer them. Yes, any questions here on campus? So yeah, you're allowed to make mistakes, so to speak. Benny asked if you're allowed to make the most things public. Yes, but if you can find like ways of solving this issue, and there are, then you do it. Yeah. So in at least in Microsoft's environment, you're allowed to like create some means of testing private stuff. It's due to my low level of knowledge of Java testing frameworks that I don't know this. Maybe you can use like the SPY or something like that by mocking to test this thing or to create this. Yes. Okay. So let's see if there's any questions. Is the change from public to private considered refactoring? Yeah, if it's done, we perhaps want to change this to something to private in the future, but then we need to update that test somehow and solve that thing. Yes. Okay. I know there are really good TDD videos out there on YouTube. Last year some student posted them, so if you find such resources, post them on Slack. If they're really good, I will post them on the course web page also. Otherwise, thank you very much for today. Listening 3 hours.